All right, we're back. We're still on page 120 something, 128. We're talking about the dot product, which we just really learned last time. So we don't know too much about it, but that's okay. We do know how to calculate it. So I am going to start calculating it here. So u is 5, and then we have kind of the unit vector in terms of the direction angle. So I know what the cosine of pi over 6 and the sine of pi over 6 is. Those are both, it's unit circle angle, so we know it. 3 pi over 4, same deal. But I don't want to do that, I think, because I think I just want to learn something here, or try to learn something. So I'm going to like just go for it and see what happens. So I'm going to say u dot v is going to be 5 cosine pi over 6 times 14 cosine of 3 pi over 4, okay, plus 5 sine of pi over 6 times 14 sine of 3 pi over 4. So this isn't looking great, except it kind of is. So I see like both of these things have 5 times 14 in them. So I'm just immediately going to take that out. 5, so UV, 5 times 14 is 50, is 70. And then, look at this, I have cosine, cosine, and then I have sine, sine, and furthermore, this is pi over 6 for both of these, and 3 pi over 4 for both of these. So I have cosine, cosine plus sine, sine. That's a thing. That's going to be the cosine of a minus b. Okay, which is 70, and then the cosine of, I guess 12, right? So 2 pi over 12 minus 9, so 2 minus 9 is negative 7 pi over 12. But cosine's even, so I'm going to say it's 70 cosine of 7 pi over 12. Now what? Okay, so I mean, that's fine. But 7 pi over 12, like what is that? I mean, that's pi over 6 minus 3 pi over 4. Well, it's the opposite of that, so it's really 3 pi over 4 minus pi over 6. What does that mean? What if I were to graph these two vectors, right? So let's see. I'm not gonna, well, I'm gonna pretend that I'm gonna do this accurately, but like secretly deep down inside, I don't care how accurate this looks. So u and v, I'll use two different colors. So u is pi over 6, right? So this is the vector u, and this is pi over 6. And then v, let's use a different color. V is 3 pi over 4. So there, that kind of like snapped, so I'm thinking that's right. Oh, wait, this is V. And so this angle is 3 pi over 4. Now, we calculated 3 pi over 4 minus pi over 6. So what we calculated is that this angle is 7 pi over 12. Well, what the heck? Like, look at what's happened here. So 7 pi over 12. This is pretty exciting. Get excited. 7 pi over 12 here. We got 7 pi over 12. And now, so it looks like when we had this, the dot product ended up 5 times 14. So the product of the magnitudes, we multiplied the magnitudes, and then we just took the cosine of the angle between the vectors, right? So we knew the two initial angles, so 3 pi over 4 and pi over 6. We're able to find the angle between them, but it looks like the dot product, so u dot v, is the product of the magnitudes, so magnitude of u, magnitude of v, times the cosine of the angle between the vectors. I don't know if I was expecting that, but that seems to be what's happened here. And maybe that's going to be something that we use. Who knows? If it is, that's a different definition, right? Because the definition we're using is the sum of the products of corresponding components. And here we're saying it's the product of the magnitudes times the cosine of the angle between them. Could be two entirely different definitions. One of them we're sure of, the other one maybe, and again, if I'm suggesting it this much, it probably is, but you never know. All right, let's see if we can do this. This feels like a linear algebra problem to me, where we're going to find these weird things and be like, oh, look at this. All right, so u dot v is going to be u1 v1 plus u2 v2 plus u dot w is going to be u1 w1 plus u2 w2. All right, and is there like anything we can do with that? Well, yeah, we can rearrange this so that the u1 things are together, right? So u1 v1 plus u1 w1 plus, and now the u2 things, u2 v2 plus u2 w2. Okay, so if we look at that, then from the first two products, u1 v1 plus u1 w1, I can take out u1, right? So this would give me u1, and then I would have v1 plus w1. And then from the second set, so what I basically did there is I took out u1, and then that left me with v1 plus w1. And now I'm going to take out, I guess this. I want to be good at using colors. I don't know. If I take out u2, I'll have v2 plus w2. So what can we color code this with? So if I take out u2 from both of these, there, and then I don't know. That's not. Uh-oh, I hate that double tap there. v2, w2, like this. Okay, so how does this help me? Well, this is something that you do a lot, and it's a little weird, but you do it a lot when you're doing like linear algebra type things. You look at something, you're like, oh, that's the dot product. What is this the dot product of? Well, this is actually just u1, u2 dot v1 plus w1 comma v2 plus w2. And then what is that? Well, that is u dot product v plus w, which is apparently the same as u dot v plus u dot w. That means that a dot product distributes across addition. And it's like, is that an obvious thing? I don't know. I don't think it's necessarily obvious. Like multiplication, matrix multiplication doesn't work that way. So like, why should a dot product? But a dot product does. These are the sorts of properties that you just like work out. There's nothing more going on there, by the way. Like, I just wanted you to see that, like, if you play around with these things, you can kind of like work out what's going on, and it's a little interesting. All right, let's try these. If I do u dot u, there's no reason to do all of these. U dot u is going to be u1 times u1 plus u2 times u2. Okay, so that's u1 squared plus u2 squared. Okay, so u dot u is u1 squared plus u2 squared. Now, here's the thing. Where have you seen that before? You've seen it somewhere, something to do with vectors, that like maybe it wasn't just by itself. Maybe it was in something, maybe it was on top of something, it was underneath, who knows, right? The place where you saw that is the magnitude of u is the square root of u1 squared plus u2 squared. So this is equal to the magnitude of u, but squared. So this is actually one of the rules. If you take a vector and you dot it with itself, not something else, you get the magnitude of that thing squared. So this is one of the properties of vectors. They have a lot of properties, and they're all weird. They're not all weird, but they're a substantial number of them are actually kind of weird. Like you would not necessarily guess them, or when you see them, you're just kind of like, oh, okay. And this one is probably one where you're like, okay, I guess I would have come up with that. Maybe I wouldn't have come up with that. When am I going to use that? Maybe we'll see. This one actually, it comes up a lot when you're like deriving properties or rules or proving something. You end up replacing one with the other. And if you don't know that that's what happened, you're just kind of like, huh, how did you go from step 1 to 2? But it's usually more like, how did you go from step 23 to 24? Because it's like in the middle and no one explains it. But anyway, now you'll know it when you see it. So I'm going to stop this here. Again, like just so much information that we learned. I will be back in the next one to do some more stuff. So I will see you there.